Yeah. I'm John.
My name is Todd.
My name is Ray.
Hello, my name is Guanhua Kai.
This is our ME157 term project. The project we have worked on is the automated pant folder. In recent years, there has been a great shift from retail stores to online shopping. As a result, shipping and packaging facilities need to maximize their efficiency. This can be achieved through automated folding and packaging processes, because ultimately this will reduce folding and packaging times, and so human intervention can be minimized. As a result of that, the need for hands-on operators is reduced, and those operators working can focus their efforts elsewhere.
Our working principles were speed, safety, and functionality. To attain the right speed, we had to select the right servo and materials. To attain a properly safe product, material selection was crucial. For proper functionality, correct measurements and calculations must be carried out.
To attain the moment at the hinges, we had to take into consideration weights for both our small plates and our large plate. So we had to take into consideration the weight of the plate itself, the maximum possible weight for any pair of pants, the weight of the rubber film that we're using for friction, and we took that as a uniformly distributed load and took the moment from there. As for the rubber coating, we took to an Excel file and put in the proper equations and noticed that we have full grip until about 57 degrees.
To find the position of our four-bar mechanism, we used graphical method. From there, we obtained our values, our vector values, as well as the angles. From here, we write our vector loop. In this case, it's position. We start off with position. From there, we use Eulers to derive the velocity. From there, you split them up from real and imaginary. You plug in your real values and do some algebra. There's two equations and two unknowns. From that, we could find our input rotational speed. To do the force analysis, we must find angular acceleration. This is done by deriving the velocity equations. We have skipped that for time constraints, and the n is shown here. Unfortunately, we cannot complete the force analysis because of time constraints. But to find the required torques and forces, we would use the angular acceleration into the 9x9 matrix. For the stress analysis, since we couldn't complete the force analysis, we assumed a static loading. As seen here, we use the weight of the pants as a distributed load. There's a bending moment on that plate. We find the alternating and mean stress and use the modified Goodman equations. Here we have to use correction factors as shown. When you plug in all the numbers, we get a very high safety factor. This is because the weight of the pants is significantly lighter than the material of the plate.
Ultimately, we were satisfied with our design. However, we fell short when it came down to our calculations. In future iterations, we would like to streamline the design and further our studies with the calculations.